Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the image overlap problem. You are given two images, image 1 and image 2, represented as binary square matrices of size n by n. A binary matrix has only zeros and ones as values. We translate one image however we choose by sliding all the 1 bits left, right, up and or down any number of units. We then place it on top of the other image. We can then calculate the overlap by counting the number of positions that have a 1 in both images. Note also that a translation does not include any kind of rotation. Any 1 bits that are translated outside the matrix borders are erased. Return the largest possible overlap. Okay. My immediate thought is I have no idea how to do this efficiently. So the naive approach, which is what I'm almost certainly going to start with because I have nothing better coming to my brain right at this moment, is basically this can be rotated up to n positions across, so it's 3 across, so we can rotate it 0, 1 or 2 positions, and we can rotate it down 0, 1 or 2 positions, sort of rolling it, and we need to do all combinations of those. And when we do that translation, we just need to check how much it overlaps. So it seems to me, well, first off, let's do the overlap. Image 1, image 2. How do we calculate the overlap of these things here? So for row 1, row 2 in zip image 1, image 2, for cell 1, cell 2 in zip row 1, row 2, overlap equals 0, overlap plus equals cell 1 times cell 2. Now the reason I can do a product here is because if they're both 1s, the product is 1, and if they're either one is 0, the product is 0. So if I sum up all the element-wise product, I get the amount of overlap. Now, what we want to do is for rot x in how do I want to do this? Range len image 1 for rot y in range len image 1. This is n. In fact, let's just do this. N is equal to len image 1. So this is range n, and this one is range n. Transform. Oop, that's not what I want to do. I want to do a self.transform on image 1 of rot x, rot y. Largest overlap is 0. Largest overlap is the max of largest overlap with self.overlap of image 1b. Image 2. And then finally we need to do this transform business. Transform self image rot x, rot y. So the rotation on the y-axis is what we want to do is we want to do 0 times len image times len rot y. This generates me y 0 rows, and I want to append that to the original image taking the first up to the length of the image minus the rotation. So the idea here is if I want to rotate 1, I need to basically add a 0 row on the top and drop 1 row off the bottom. That gives me a 1 rotation down. And then it's for I row in enumerate image I is equal to 0 times rot x plus image I sliced up to len image minus rot x, and this is exactly the same thing. Oh, frog in my throat. This is exactly the same thing, now just applied to each row. So to rotate across by 1, I need to add 1 0 on the front and then drop the final 0 on the end. I do that for every row. So I finally return image. This does not seem efficient at all. There's a lot of copying. It's what? N to the 4 complexity, which isn't amazing. Well, I'm not sure you can do it much quicker. We'll find out. Let's first off see if this even works. Okay. It passes the very first test case at least. Let's use the rest of the example test cases. It passes all of those. If this works, we're going to be very lucky. But I suspect it's not efficient enough. We will see. It's not that it's not efficient enough, it's that it just doesn't work. That's unexpected. Show me what is happening. So this is 00001. Oh, heck. We also need to potentially rotate from -n plus 1. Ugh. Can you show me what you're making at each point? Image 1b. Oh, yeah, here's the problem. If rot y is less than 0, image needs to be similar to this, but what we want to do is want to take the original image, dropping the first number of things. So if I'm rotating -3, let's go back here. Let's say I'm rotating -1 up. So I'm rotating up by 1. I want to take everything except the first one and then add on zero times len image times rot y. Yeah, if rot x is x less than 0, else. Same thing down. Image I is equal to image I dropping the first. Oh, in fact, that could be a negative rot y, couldn't it? Then image minus rot y, then image minus rot x. That's just a negative rot x. That's a nice symmetry then. Plus 0 times rot x. Let's see what that does. Oops, that's times negative rot y times negative rot x. That's interesting. 0 times negative 5 still gave me 5 zeros. Ha! Fun. So now here it's actually... Oh, that's a problem. Why is it producing empty lists? It should absolutely not be producing empty lists. Print rot x, rot y. -4, -4. Why is that all zeros? 1, 2, 3, 4. Oh, of course, -4. If rot y equals, let's handle the 0 case specifically. Image is image sliced. If rot x equals 0, pass. No, I want to make sure I'm not accidentally manipulating it. So now -4, 0. Yeah, that's what we're after. I think we were getting lucky before that we were passing that test. Okay, let's use the example test cases again, just to make sure I haven't broken anything in the meantime. Looks good. Still worried about speed. This is not quick code. I'm hoping the bounds are small, because they could only be 30s by 30s. No, we've time limit exceeded. We can know something about how many zeros we're going to have. So for example, if abs rot x, so if we've rotated x by a certain distance, that's going to guarantee let me just work inside a comment here. Abs rot x times n. That gives us the number of 0 columns we've introduced, plus abs rot y times n gives us the number of 0 rows the number of zeros we've introduced on the rows. And that double counts. What is that? The rot x times rot y. If we've rotated one that way and one that way. Then we've introduced one overall. We've introduced 1 and 2. That's introduced 2 things that are in both sets. So we've counted rot x times rot y twice. So this is the number of zeros we have definitely introduced. Actually, is that that's a point. We don't need to do any shifting at all. Oh my god, light bulbs are going off. I have completely misunderstood how this problem works. I was doing this very literally, and I was actually rotating this thing. But if we imagine we've shifted this down 1 and across 1, all that's saying is index this up to the negative, and the negative, and this one start indexing there. Oh my god. Okay. So, in fact, here is where we want to do this. So we don't want to do a transform at all. So its overlap is self.overlap image 1, image 2, rot x, rot y. But down here, well, we can get rid of all this crap. Image 1, hang on, let's do this. If rot x is equal to 0, well, let's do all the cases, just because that's easiest. So if rot x is 0, if rot y equals 0, this case is still correct. And if rot y is greater than 0, what I want to do is I don't want to start indexing this one here. If I rotated this up or down by 1, image 1 I still want to start indexing there. But I want to go until negative rot y. I want to drop the last thing. And this one here, I want to go from rot y onwards. In fact, no, this rot x is in the wrong place. So I'll leave that there for now, but we'll come back. If rot x is greater than 0, else pass. If rot x is equal to 0, we'll probably be able to find something nice here in a minute, but for now, fill in all the gaps. I just want that again. So this was for rot, and this guy here now goes from negative rot y up to rot y. So if I'm rolling by negative 1, I want to effectively roll this, hang on, so if this is greater than 0, I'm rolling this down, so it's as if I'm only doing the first 2 rows, so that's up to negative 1, and this one here, it's as if I'm starting from 1, but But if I'm rolling the other way, it's as if I'm starting from 1, and here I want to count only up to ignoring the last thing. So that's correct. Yeah, so the colon switches sides in Python. That's the trick. So then for this is where we want to do something similar. If rodx is greater than 0, this is where we want to do our slice up to negative rodx, and then slice from rodx. So if I'm shifting these across by 1, that says if I was actually starting... No, that says if I dropped the last thing. And if I... so on this one here, to keep it balanced, I'm only going to... I'm going to drop... No, hang on. This is like dropping the last thing. So here I want to skip the first thing. Yeah, there we go. Holy moly, this is a little bit of a brain melt. This is, I suspect, not as hard as I'm making it, but it doesn't quite fit my brain. So now that inside is actually what I want. Hang on, let's do this differently. The complex row 1, row 2. Let's put all that in there. This needs to be a non-local overlap because we're mutating. So this now is complex of row 1, row 2. Same again. Whoops, but only going to there. Only going to there. Okay, does this work? Oh, that looks like it worked. Let's go back here. It's not even that big, actually. Well, compared to some of the ones we've seen in the past where it takes my browser seconds to load the page. There we go. Now we're getting somewhere. I am a little worried because these are slices, and Python isn't super efficient with its slices, but I'm hoping it'll be okay. We can fiddle these into indices if we need to. Right. Let's submit it and see what happens. Hey! There we go. That's quite cool. I had just... Oh, I was a bit slow and actually realizing what the question was asking me to do, but we got there. That's quite cool, actually. I had not thought that. I was very much going down the view of, oh, I need to slice this thing and move it around and make copies, but I don't. I just need to change how I'm actually doing the comparison. It's actually exactly the same complexity in both. It's order n to the 4, but it just doesn't do all of that copying. And that is what saves us time. So that's quite cool. I do hope you enjoyed. Do let me know how you got on with this one, because this is quite a cool problem. It took me a while to spot what's going on. Let me know in the comments. Do remember to like, comment, subscribe, all of that good stuff, and I will see you next time. Bye.